All right, my geometry students, this is section lesson 7-2, and it discusses the exterior angle theorem, which is a pretty cool theorem to use and utilize for determining measurements of angles and proving all sorts of things. So we are on page 282, and again it's 7-2. Exterior angle theorem on 282. So I got to get to that page also. It's a page break actually on 281L in Braille. And it always starts out with the what you'll learn and why it's important stuff, and then turn the page to 282A. And in print we're on page 282. All right, and it's going to discuss, it starts out in the figure at the right. Recall that angle 1, angle 2, and angle 3 are all interior angles of triangle PQR. Angle 4 is called an exterior angle of triangle PQR. An exterior angle of a triangle is an angle that forms a linear pair with one of the angles of the triangle. So lots of things should sound familiar. Interior angles of the triangle, your brain should kick on. Oh, those all add up to how many degrees with the angle sum theorem? 180. And now I'm learning that I've got an exterior angle. That sounds like it should be on the outside of my triangle. And when it's sitting right next to one on the interior, you're going to notice that, oh yeah, it forms a linear pair. And you learned long ago that a linear pair means two angles adjacent to each other that form a line, or if added together, are how many degrees? Hopefully you're all shouting out 180. So if you look at the drawing on your Braille page, and print users immediately to the right, we have vertex P at the very top. You have an outline of a triangle, so down at the bottom left is vertex Q, and at the bottom right is vertex R. And from Q to R, going west, headed east, the bottom extends, and there's an arrowhead. They just extend the base of our triangle. In the interior of the triangle, they label our angles 1 at vertex Q, 2 at vertex P, and 3 at vertex R. And then the linear pair, or the exterior angle, to angle 3, they label 4. So that angle 4 is the exterior angle of our triangle PQR, and it's the linear pair with angle 3. Down at the bottom it says, in triangle PQR, angle 4 is an exterior angle at R because it forms a linear pair with angle 3. Remote interior angles of a triangle are the two angles that do not form a linear pair with the exterior angle. In triangle PQR, 1 and 2 are the remote interior angles with respect to 4. So a couple terms. You've got 3 terms really. You have interior angles, that's angle 1, 2, and 3 of your drawing. You have an exterior angle, which is angle 4. And then angle 1 and 2 are the remote interior angles with respect to 4. So angle 4 is the exterior angle to angle 3. It's a linear pair with angle 3. And then 1 and 2 are considered the remote interior angles with respect to 4. We say with respect to 4 because if we extended one of our sides in another direction and created another angle like angle 5 on the exterior, that would be a linear pair, let's say, to angle 1, well then 2 and 3 would be the remote interior angles with respect to angle 5. Fancy language, isn't it? All right, turn the page, Braille page 282B, and it says, should say, it finishes up the information about the remote interior angles, and then it starts, each interior angle has corresponding remote interior angles. How many exterior angles does triangle XYZ below have. So you'll see that they have a triangle and they've extended each one of the sides so that it creates a little double arrowhead at each vertex. So at the very top vertex, they've labeled it Y. And there's two arrowheads. And then if you follow one of the arrowheads down to the left from about 1 o'clock to 7 o'clock, you go through another arrowhead. That's one side of your triangle, and that goes through that they're labeling that X, vertex X. And from vertex X, you have another arrowhead, and you follow that immediately right through a line through another arrowhead. And they've labeled that vertex Z. At vertex Z, they have two arrowheads. You find that other arrowhead at about 5 o'clock, and you follow that back up to 11 o'clock, back up to your vertex Y, to another arrowhead. So they've extended each side. That's all they've done. It's a triangle, but they've extended each one of its sides, made them the lines that they are. And then they've labeled all the angles that get formed. Well, not all of them, but a bunch of them. So at Y, we have an angle on the outside of our triangle on the left, labeled 2. An angle on the exterior of our triangle labeled, excuse me, not 2, 5. My apologies, 5. And then to the right, angle 6, those are both exteriors, and then the interior is a 2. So 5 is an exterior to angle 2, and 6 is an exterior to angle 2. Then down at vertex X, we have an interior angle of 1, and we have two exterior angles to 1, one immediately to the left, angle 4, and then one below it, angle 9. And then at vertex Z, you have an interior angle of 3, and two exterior angles, angle 7 immediately to the right, and angle 8 just below it. Now notice that they did not label the angles, the vertical angles to each of the vertex. So the vertical angled angle 2 that would have been sandwiched in between the two extensions of the side, they didn't label those. Those are not exterior angles because they don't meet the definition of an exterior angle, which means that it has to form a linear pair with an interior angle. And then it's saying, okay, well, how many exterior angles does XYZ have? Well, we can count them. 1, 2, 3, 4, 5, 6. 6 of them, all right? So it also says, notice that there are two exterior angles at each vertex, and those two exterior angles have the same remote interior angles. Also observe that an exterior angle is never a vertical angle to the angle of the triangle, right? So the exterior angle number 5 has remote angles 3 and 1. The exterior angle 6 also has 3 and 1. That would make sense. They're the two other angles that aren't being used with that current interior angle, angle 2. When you go down to angle 1 in the bottom left, you have exterior angles 4 and 9, so the remote interior angles to those exterior angles would be 2 and 3. And if you go to vertex Z with the interior angle of angle 3, you have two exterior angles 7 and 8, and the remote interior angles to both 7 and 8 would be 1 and 2. Things to kind of put in your head to think about. The next page details a table that talks about each exterior angle, and if you want to read through that, you may. On 282, there's a music stand that says semi-okay Braille. We can exclude a lot of stuff. We want to try to find the triangle right in the midst of it that they're going to. So we have an arrow that goes from 12 o'clock, or actually it's a ray that goes from 12 o'clock to 6 o'clock. So find that. And then at an angle to the left from about 2 o'clock to 8 o'clock, there's a side of our triangle. And then we go back to along the base to the up and down ray. So they're taking a look at this triangle on the right, and then that base extends a little bit to the right with an arrowhead. So you got to kind of make out that triangle in the midst. And they've labeled the interior angles, so that might help you at each vertex. They've labeled the left vertex, the bottom left vertex 3. the interior angle 3. The top vertex they've labeled the interior angle 2, and the exterior angle, they've labeled it a 1. So if we go immediately above 2, you find a 1. So that's your exterior angle to the interior angle 2. And then at the bottom right, you have angle 4 on the interior, and then immediately to the right, you have angle 5 as its exterior. So it says in the music stand, name the remote interior angles with respect to angle 1. So angle 1 is up at the top left. It's hanging out with angle 2, so you know the remote interior angles with respect to that would be the two angles inside your triangle, 3 and 4. Those would be the remote interior angles. Then it says in the your turn, in the figure above, angle 2 and 3 are remote interior angles with respect to what angle? So you got 2 and 3, so you know those are your remote interior angles with respect to what exterior angle. So you have to go find your other interior angle, which is 4, the bottom right, and the exterior angle is 5. So 2 and 3 are remote exterior angles with respect to angle 5. Well, that just helps you kind of play with some interesting vocabulary and terms about exterior angles and remote interior angles. There is, on the next couple pages, a hands-on geometry about using a straight edge to draw and label a triangle, which they already did for you. So we can use this, and then we can think about what's going on. So find on page 283, A, we have a triangle, RPN. R is the bottom left, P is the top, and N is the bottom right. And then there's, it extends at the base from R to N. It extends to the right further through another point, K, and then there's an arrowhead. And in the interior of the angle, they've labeled your interior angles at vertex R, angle 1, at vertex P, angle 2, and at vertex N, angle 3. And then immediately to the right, the linear pair with 3, they're labeling 4. So you've learned, okay, angle 4 is an exterior angle. It's a linear pair with angle 3. The remote interior angles would be angle 1 and 2. And we want to find the measure of the angles. And so if they give us in a table that the measure of angle 1 is approximately 31 degrees, and the measure of angle 2 is 103 degrees. Well, we know by angle sum theorem we could add 31 and 103, we get 134. Subtract that from 180, and we could get the measure of angle 3. So 31 and 103, 134, minus 180, what do we get? 46, right? 46 degrees. And then you know by the linear pair rule that if you were just given that, you could figure out number 4. Well, 180 minus 46, oh, check that out. We get 134 degrees. Aha! And if we kept doing that, if we were given just 103 and 41 and 46, we would constantly figure out that the exterior angle is the sum of the two remote interior angles. And that leads us to the exterior angle theorem, which is theorem 7-3. So if you turn your page, a couple pages, let's see, yep, we got to get a couple pages over on 283C, you're going to get to theorem 7-3, the exterior angle theorem. And in words, it says the measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. And so it gives a model, has a triangle X, Y, and Z. Y is your top vertex, X is your bottom left, Z is your bottom right. They've extended the side XZ to the right with an arrowhead. They've labeled the interior angles at X number 1, at Y number 2, and at Z number 3, and the exterior angle number 4. And it's just showing then in symbols down below that the measure of angle 4, the measure of that exterior angle, equals the measure of angle 1 and angle 2. It equals the sum of the remote interior angles. And that should make sense. Think about this. How much is total on the inside of a triangle? 180, right? Well, how much total is a linear pair? 3 and 4, 180. So if you want to figure out what 4 is, and you knew 1 and 2 and not 3, you could just add 1 and 2 together, because they would have to add together to number 3 to get 180, just as number 3 would have to add together to number 4 to get 180. So the measure of an exterior angle is the sum of the measures of the two remote interior angles. And on the next page, Braille page 284 and print page 284, they have example 2, the measure of angle 2 equals 38, the measure of angle 4 equals 134. What is the measure of angle 5? And again, there's a drawing at the bottom, and they've extended a few of the sides. So you got to kind of make out this interesting triangle with extensions and arrowheads on its sides. But they just want to extend them so that they can show the exterior angles. All right? And so you have a top side going from about 8 o'clock to 2 o'clock, and then a right side going from about 11 o'clock to 5 o'clock, and then a base that goes west to east. The interior, they've labeled the bottom left angle 2, and the top angle 5, and the bottom right angle 3. And then the exterior angles at the bottom left, they've labeled a 1. At the top right, they've labeled it 6, and at the bottom right, they've labeled it 4. And you're told that the measure of angle 2 is 38 degrees. The measure of angle 4 is 134 degrees, so that's an exterior angle. The measure, and then that's it. That's all they're giving you. What is the measure of angle 5? So it walks you through the process on the next page, and it says, if the measure of angle 4 equals the measure of angle 2 plus 5, that is because of the exterior angle theorem. So that measure of angle 4, it equals 2 and 5 together. So using the substitution property, you can plug in the value of 134 for the measure of angle 4, plug in the value of 38 for the measure of angle 5, or excuse me, 2, and then say plus the measure of angle 5. That's your unknown. So using your addition or subtraction property of equality, you subtract 38 from both sides, and you figure out that the measure of angle 5 is 96. And to check it, you add 96 and 38 back together, and you should get 134. Right? You can turn the page, and then there's also an algebra link. Oh, great. Everybody loves the algebra review and algebra link. But it says if the measure of angle 2 equals x plus 17, and the measure of angle 3 equals 2x, and the measure of angle 6 equals 101, find the value of x. So you got to go back to your drawing, and you go, okay, I have this angle 6. That's an exterior angle at 101 degrees. I know that has to equal the two remote interior angles, which would be 2 and 3. They give me 2 at x plus 17 and 3 at 2x, so I have to add those two together. So let's look at the proof. Let's look what they do. They say the measure of angle 6 has to equal the measure of angle 2 plus the measure of angle 3 because of the exterior angle theorem. Then they replace the measure of angle 6 with 101, the measure of angle 2 with x plus 17, and the measure of angle 3 with 2x. They use that substitution property. And then we got to combine like terms, don't we? Simplify a little bit. So 101 equals 3x plus 17 because they combine the x and the 2x. And then now it's basic algebra. We need to subtract 17 from both sides because of the subtraction property of equality. Simplify, and we get 101 minus 17 is 84, and that equals 3x. Divide by 3 on both sides because of the division property of equality, and x equals 28. And all it asked for was find the value of x. It didn't say find the measure of the angles. If it would have said find the measure of angles, we would have substituted in that x value into our expressions to find those, right? And in the your turn, it says refer to the figure. What is the measure of angle 1 if the measure of angle 3 is 46 and the measure of angle 5 is 96? So you look at the measure of angle 3, go back to your drawing. What is the measure of angle 1 if angle 3 is 46 and angle 5 is 96? Okay, they're giving you the two remote interior angles to angle 1. And you know by angle sum theorem, or angle exterior, exterior angle theorem, that angle 1 has to equal the sum of the two remote interior angles. So it's got to equal 3 and 5 together. So all you got to do is add those two together to get angle 1. That's no big deal. And then in little letter C, they push you further. On the next page, they say if the angle 2 equals 3x and angle 3 equals x plus 34, find angle 6 if it's 96 or 98. This is just like the last problem. You have to have the measure of angle 6, that exterior angle, equals the two remote interior angles added together, angle 2 and angle 3. You substitute in all your values. 98 equals 3x plus x plus 34, and do the algebra and get your answers. All right, there's still more information to this section. Let's keep going. We have, it says here in the next paragraph, there are two other theorems that relate to the exterior angle theorem. In the triangle at the right, the angle QRS is an exterior angle, and angle S and T are its remote interior angles. The exterior angle theorem states that the measure of QRS equals the measure of angle S and angle T. Sure enough, they have this triangle. S is your top vertex, T is your bottom right, and R is the bottom left. And then T extends to the left through R and through a point Q and with an arrowhead. QRS is the exterior angle. They're saying that's 110 degrees. And at S, they have a little line squiggly going outside the triangle saying that's 40 degrees. And at T, they have a little squiggly going to the outside of that vertex saying that's 70 degrees. And so if you check it, you go, oh, that's right. I know that the remote interior angles of an exterior angle got to add up to equal it. And sure enough, that angle on the exterior, the remote angles would be at vertex S and T. If I add 40 and 70 together, I get 110. 110 equals 110. So it goes on to state on the next page, in triangle RST, you can see that the measure of angle QRS is greater than the measures of both S and T, because 110 is greater than 40 and 110 is greater than 70. This suggests theorem 7-4. So we're going to bring into this our inequality theorems. So in words, in theorem 7-4, it says the measure of an exterior angle of a triangle is greater than the measure of either of its two remote interior angles. And that should make intuitive common sense. If two things are going to add up to one thing, the one big thing is always going to be bigger than any one of its parts. And it just gives a model of a triangle, X, Y, and Z. And in symbols, it's going to state the same theorem, kind of state the obvious. We have interior angles of 1 at X, 2 at Y, and 3 at Z, and then an exterior angle at Z at 4. And in symbols down at the bottom, it says the measure of angle 4 is greater than the measure of angle 1, and the measure of angle 4 is greater than the measure of angle 2. And if you turn the page, we practice using that a little bit. In example 4, it says name two angles in triangle MAL that have measures less than 90. So if we take a look at this, we have M at the top left vertex on our drawing, L at the bottom left. There's a right angle indicator to the exterior of that. And then A at the bottom right, that's the outline of what kind of triangle? A right triangle, right? Because if we have an exterior angle at L that's 90 degrees and it's a linear pair to an interior one, that one's got to be 90 degrees, right? So at M, they're labeling it 1. At L, they're labeling it a number 3. And at A, they're labeling it a 2. And then there's a point C that it goes through. So CLM is 90 degrees, or MLC is 90 degrees. Therefore, angle M and angle A, the two remote interior angles, are going to be less than the measure of angle MLC and the measure of angle 3 because of our exterior angle inequality theorem. All right. It also should make sense with the right triangles that the two other angles will be acute. They'll be smaller than that third angle of 90 degrees. Right? They have you practice on the next page. Under your turn, it says name two angles in triangle VWX that have measures less than 74 degrees. So you take a look at your triangle, your drawing. You have X at the top vertex, V at the bottom left, and W at the bottom right. XW, the right side, extends up with an arrowhead to create an exterior angle. That exterior angle is 74 degrees. They've labeled the interior angles angle 1 at V, angle 2 at X, and angle 3 at W. So we know the exterior angle, 74 degrees, what are its remote interior angles? Those would be 1 and 3. So we know that 1 and 3 are going to be less than 74. They got to add up to be 74. Neither one of them can be equal to 74. Right? So doing these examples, in example 4, it says the results of example 4 suggest the following theorem about angles of a right triangle. And that would be on the next page. You should say Theorem 7-5. I find it. Oh, nope, it's still on this page. I'm sorry. Very bottom of Braille page 285B. It says Theorem 7-5. If a triangle has one right angle, then the other two angles must be acute. And you learned this back in your right triangle chapter. That if you got 90 degrees, you're splitting up the other 90 degrees. Because 90 and 90 is 180. So they're always going to be less than 90. They're always going to be acute. Okay? And that is the end of section 7-2. For extra practice, I would advise doing the Check Your Understanding on page 286, number 3 through 8. And for further practice, do exercises number 9 through 25 on page 286 to 287. All right, we'll see you in the next video.